Hello and welcome to the Properties of Matter lecture. This lecture is broken up into two separate parts. This first part is Properties of Matter. The second part will be phases or states of matter, and we'll get to that later. But first, let's go ahead and begin with Properties of Matter. First, let's get the definition of the word matter. Chemistry is the study of matter and the changes that it undergoes, so probably a pretty important vocabulary word to know. So, what is matter? Matter is anything that has mass and takes up space. Mass being the scientific way that you would say the weight. The difference between weight and mass is that weight accounts for the gravity on Earth. Mass is, whatever something is made up of without taking into account gravity. So in science, we prefer to use the word mass instead of weight because it's universal. And takes up space right here, that is volume. So what is matter? Is sound matter? Is a desk matter? What about your hair? Are your thoughts? Is that made up of matter? What about the air? The cell? What about light and love? Do me a favor and in your notes, answer each one of those. Are those matter? Tell me yes or no and show that to me in class. Okay, so a substance is the next vocabulary word, and it is matter that has uniform and unchanging composition. So let's look at that a little more closely. Matter. So a substance has mass and takes up space. And it's uniform throughout. So think of people in the military who wear uniforms. What is that? What's the purpose of that? Well, it makes them all look exactly the same. So if something is uniform, then it's exactly the same all the way through it, and unchanging. That means that, if you magic school bust yourself down and looked inside of a substance, a pure substance, then you're going to see exactly the same thing all the way throughout, and you're not going to see a little floaty of something different in there. So it's unchanging. It's going to be very samey, very boring essentially in there. And then composition is what something is made up of. So substance is matter that is the same throughout, and there's no little surprises going on in there. And sometimes we call that a pure substance. This is completely interchangeable. It just depends on who's talking. Some examples of a substance: table salt is a pure substance. And yeah, it's made up of sodium and chlorine to create sodium chloride, which are chemically combined together. So if you look at table salt, if you, again, magic school bust your way down into there, you would have little Na attached to a little Cl, but it's that same little dude all the way through. And so it would look like, think of like a regiment of army guys and women in their uniforms all the way through, no matter what. And then you look at water, and you've got a little water molecule. There's your oxygen with its little hydrogens stuck to it. And you go all the way through water, and you're going to see that same little molecule. It may be facing a different direction, but it's going to look exactly like that all the way through. You're not going to see like a little aluminum atom floating around in there. So it's uniform. It looks just like that, and it's unchanging. There's no surprises in there. So both of those, sodium chloride or table salt and water, are pure substances. But so then, if you put those two things together, you're going to get a glass of salt water. And if you were to make yourself really small and go look inside of salt water, is that a pure substance? Well, here it is matter. It has mass and it has volume, but it's not uniform throughout. And what does that mean? Well, you have a bunch of these little dudes, a bunch of little waters. And the sodium chloride it's still there. They're not granules that you can see anymore, but all they've done is dissolved. They haven't chemically changed at all. So it's just water mixed in with your sodium chloride. So think about it like if these guys were your little army guys and these guys were your little marine guys. They all have their own uniforms on, and when they're separate, they're uniform throughout. But when you put them together, they're just milling around. They don't create some like mega different military unit with a different uniform, they don't change clothes, they stay in their own uniforms, and you can tell which one is the sodium army guys, or sodium chloride army guys, and which ones are the Marines little water guys. So that's how you know that is not a pure substance. Why do you have to know what a substance is? This is something that I go back to a lot in this class. I want you to, every time I teach you something, I want you to be asking, why is she bringing that up right now? Why do we have to know this? Why is this important to this subject? So we're beginning right here. Why do we have to know about substances? Well, remember that chemistry is matter and the changes that it undergoes. So most of this course focuses on substances, which is a huge part of matter, and those substances as they change into other substances. So it's really a basic part of chemistry, and that's why it's important. Okay, physical properties of matter. This is an important vocabulary word, physical property. That is something that you can observe, you can hear it, you can see it, you can smell it, and that's not going to change the sample's composition. So just by looking at it, it's not going to change the composition of it. Just by touching it, it's not going to change the composition. Things that are physical properties are density, color, odor, how something tastes, the hardness factor of it, the melting point, so at what temperature does it melt, at what temperature does it boil. These are all physical properties. There are two types of physical properties, extensive properties and intensive properties. An extensive property depends on how much of the substance you have present. So mass, length, and volume, whereas an intensive property does not depend, it's independent of the amount of substance present. For instance, density, color, and smell. So think of it this way. If you have a hunk of something, a hunk of rock or something, and you're looking at the properties, the physical properties of it, what's its mass? It weighs, I don't know, 24 grams, as opposed to what color is it? It's silver in color. Well, let's think about it. An extensive property, if I were to cut that little chunk of something, rock, in half, the mass of it, the 24 grams, is not going to be 24 grams anymore. That would have changed. So that's an extensive property. But it would still be silver. That would not have changed. So the color is intensive. So think about it that way always. Is it extensive or intensive? Well, you're going to have to memorize, the definitions of those. But then think about it. If I, bite off a piece of it, please do not do that in a lab, or just cut it in half, is that going to affect the qualities of that property? If the answer is yes, then it's extensive. If the answer is no, then it's intensive. All right, here's a note check. Look at this picture. It's a pretty bowl over here. And give me some physical properties of this bowl. And let me know, are those extensive properties or are they intensive properties? And then show that to me in class. All right, why in the world would we need to know intensive versus extensive properties? This is probably the first time you've ever come across these two words. And, well, let me tell you, there's a really good reason why we need to know whether a physical property is intensive versus extensive. It's because a lot of times when you work in chemistry, especially in a lab setting, you can have substances that are brought in and you have no idea what they are, and it's your job to figure out what in the world have we got here. So let's say that you're working in a crime lab and somebody brings in a little hunk of something and says, what is this? Well, the intensive versions are going to help you identify what you have. So think about it like you have something, and regardless of how much you have of it, the color stays the same, the melting point is going to stay the same. All these different factors are going to stay the same, and because they don't change based on how much you have, the density, etc., then you can use these characteristics to help you at least get you started on identifying what you have. Look, I've been talking about hunks of something, and here are a couple of pictures of hunks of something. So pretend somebody's brought this into you, and they need to know what these are. Are they the same thing? Are they not the same thing? So let's start by giving me in your notes, and then show it to me in class. Give me some intensive properties of both of these little hunks of something. We're moving on to chemical properties now, but before we do that, I want to make a quick note about intensive versus extensive properties. Please remember that those are just dealing with physical properties. So now that we're moving on to chemical properties, intensive versus extensive, not a factor anymore. All right, so we've got a new vocabulary word, chemical property. Chemical property is the ability of a substance to combine with or change into one or more other substance. So if we're using the same strange analogy of little army guys mixing with little marine guys, then think about it this way. If it's a physical property, they're just going to stay in their same uniform. They're not changing who they are, or anything about themselves. But if it's a chemical property, then if there's a change going on, then if you put those two together, then what would happen is they would change uniforms. Like sometimes, you have your special forces, and so you put like an Army Ranger in with a Marine. They would need to kind of look alike. So the two would dress alike to go on a mission so that they are all camouflaged and you can't see them. So in that case, they have both changed into something new. They're a different special forces unit. That would be an analogy for a chemical change. Whereas if they're just, at some sort of event where they're all wearing their same uniforms, that would not be a chemical change. That would be a physical change. So a chemical property is some description of matter where it would cause a change in the substance. Or the opposite of that is the inability of that substance to change into another substance. Please remember that that is also a chemical property. So some examples, anytime you have iron rusting or any form of oxidation, that's a chemical property. Flammability is something able to catch fire, or here is it not able to catch fire. That also is a chemical property. And of course, anytime you see something that forms a new substance, chemical property. Here's a fun picture. So we've got a penny in some liquid, and in your notes, a new note check, give me some chemical properties of what's going on here. So chemical properties. One of the fun things we get to do in chemistry are flame tests. Anytime we get to set things on fire, it's scary. It truly is. But it's also a lot of fun. So different chemicals, the way we can help identify them is that they have different colors that they burn at. And so that's called a flame test. When you set something on fire, very small amount of fire, to see what color the flame is, it's a lot of fun. We do that. So here are a couple of different chemicals. One is burning green, and it looks like one is burning a sort of yellow. It's hard to tell what color that one is. It might be white, and it might be blue. We've got some different temperatures going on there. Or we could have different chemicals burning off at different temperatures right there. Here's an example of rust. As you can tell, iron is oxidizing. That means it's reacting with oxygen to create rust. Fun fact, the Statue of Liberty originally looked like this. She's made out of copper, so think of your pennies. She originally looked like a penny, only statue-y. And over the years, she has oxidized. Again, she has reacted with oxygen to create this beautiful patina or this green color. And if you notice, your pennies do the exact same thing. And if you remember back to that penny picture that I made you give me some chemical properties of, you would have noticed a very similar color. That's copper reacting. So next time you see the Statue of Liberty in a movie, or you happen to be there in person, note that that color is 100% due to a chemical change that she has undergone. That her color is a chemical property. Fun, right? Here's a question for you, and I'm not going to give you the answer right now. I want you not to go look it up. I want you to answer this, just think. I want you to sit there and I want you to think. And then I want you to put it down in your notes, your answer, and then I want you to show it to me. So answer it before you go look up the answer. And don't bother going to look up the answer. I'll tell you at the end of the next slideshow. So here's the question. What is the most common state of matter in the universe? You're going to have to know a couple of things. What's the state of matter? Well, give you a little bit of a hint. That's what we're going to learn in the next section. You already know it, though, please. You learned that in, the 5th grade. So what is the most common state of matter in the universe? Put it in your notes. Show me. Let's see if you get it right. Don't cheat.